Hello my dear students, let us discuss about water requirements of crops. Before studying water requirements of crops, first you should know what are the different types of soil water or soil moisture. When water fills the soil surface by irrigation or by rainwater, it is absorbed by the soil. All of us know this thing. The amount of absorption is different for different types of soil. The water absorbed by pores is called soil water or soil moisture. Okay. So when the water is supplied either by irrigation or rainwater, that water is absorbed by the soil. So the water absorbed by pores in the soil, that is called as soil water or soil moisture. You can see here, these are the different types of water: hygroscopic water, capillary water and gravitational water. Okay, see here, the remaining water adheres to the soil particles, and in this water held in micropores, and the gravitational water drains right through. Okay, this point is called as field point, wilting point, and next this point is called field capacity. We'll discuss this later. So this is the overall the water content of the soil, soil and water diagram. Here you can see this portion of the water that is in the soil. It is called gravity, and this is capillary water, and this is hygroscopic water. Okay, till this water saturation to field capacity, this is the portion, field capacity portion, that is gravity water. Field capacity to the permanent wilting point, that is capillary water, and below that to the dry state, that is hygroscopic water. Okay, this is percolation after irrigation and storage for plant growth. This is the total soil moisture. So now we'll see what is gravitational water. It is that water which drains into the soil under the influence of gravity. Here, water that drains through the soil into the water table, not usually considered as available to plants. Okay, this water is not available for the plants. After irrigation and rainfall, this water remains in the soil and saturates it, preventing circulation of air and void spaces. Okay, this is about gravitational water. Then capillary water. Here, below the gravitational water, a part of water held by the soil by the capillary action of the surface tension force against gravity. Here, this water is available to plants. So, plants can absorb this water. This part of water is absorbed by the root zone of the crop. This is about capillary water. Then hygroscopic water. Here, water attached to soil particles through loose chemical bond is termed as hygroscopic water. Here, not usually considered as available to plants. This water also not available to the plants. This water can be removed from the soil only by the application of heat. During drought situation, plant roots can extract small fraction of this water. Only during drought situation, the plant can absorb this water. Okay, so these are the three different types of the water present in the soil. Next, let us discuss about field capacity. Field capacity is the moisture content or water content of a soil after it has been saturated with water and the excess water has drained away. Okay, this is the saturation with the water. Soil is saturated with the water and the excess water has drained away. The water in the soil at field capacity is held by capillary forces, and clay soils have a high field capacity because voids are less, so it has the better capacity to retain the water, so it has a high field capacity. And sandy soils have a low field capacity because the many voids are present in the soil, sandy soils, so it has the less retention capacity of water, so it has a low field capacity. So it is nothing but it is the status of the saturated water and excess water is drained away. So this is available to the plants. Permanent wilting coefficient or permanent wilting point. This is the water content at which plants can no longer extract sufficient water from the soil for its growth. So this water is not available for the plant. Here this plants cannot extract the sufficient water from the soil in this condition. It is the lower end of available moisture range. At this point, wilting of the plant occurs. It is usually expressed in percentage. Okay, so this is about the field capacity and permanent wilting point or wilting coefficient. Okay, next you can see here in this diagram it clearly you can understand clearly. So this is the saturation point. Saturation condition. All pores are full of water. Here all the portions are filled by water. Gravitational water is lost. Okay, here these are the soil particles. In between there are pores and these pores are filled by water. And here this is the field capacity and means this water is available for plant growth. And after that wilting point, here no more water is available to the plants. There is no water in this situation. Okay, all the waters are already absorbed by the plant, so no more water is available to the plant. So this condition is called as wilting point. Next, we'll discuss some of the factors which affects the water requirements. The first one is water table. Depending upon position of water table to ground surface or much below, water requirement may be less or more respectively. Okay, if the depending upon the position of the water table, if the ground surface is much below, then water requirement may be less. Okay, if it is little bit it is not so much below, then water requirements may be more. Okay, then climate. The evaporation loss in hot climate, hence water requirement will be more, and in cold climate water requirement will be less. Then type of the soil. If the soil is porous, means it is filled with the voids, that is sandy soils, water percolates quickly. So retention of water is less, therefore water requirement is more. But in the clay soil, water requirement is less because the pores are filled with the water. So retention capacity is more, so water requirement is less. And method of ploughing. In deep ploughing, soil can retain water for a longer period and water requirement is less. And then intensity of irrigation. Intensity of irrigation means the ratio of area under cultivation to the total culturable area. Okay, it is the ratio of area which is under cultivation, means it is to be irrigated, to the total culturable area, means the total land available for the irrigation. If this intensity is more area is under cultivation, hence water requirement is more. Then ground slope. In steep ground water, flows down quickly, finds the little time to absorb required amount of water, hence water requirement is more. For flat slope, water flows slowly, finds enough time for absorption, hence water requirement is less. Next method is method of application of water. In surface flow irrigation, evaporation is more, and in subsurface irrigation, evaporation loss is minimum. Hence, water requirement is more in surface irrigation than subsurface irrigation. These are the some of the points about the water requirements of the crops. And next we will see what are the cropping seasons of India. Okay, here in India, the cropping season is mainly classified into under two main seasons. One is Kharif and other one is the Rabi. The crops grown during these crop seasons are designated as Rabi crops and Kharif crops. The Kharif crop season from July to October during the southwest monsoon, and the Rabi cropping season is from October to March, that is the winter season. And the crops grown between March and June are summer crops. Okay, so three types of crops. One is that is Kharif, Rabi, and the summer crops. The term Kharif and Rabi originates from Arabic language, where Kharif means autumn and Rabi means spring. Okay, some of the Kharif crops include rice, maize, and sorghum, pearl, millet, bajra, finger millet, ragi, groundnut, and cotton, etc. Under Rabi crops, which includes wheat, barley, oats, uh, and chickpea, gram, linseed, mustard, oilseeds, etc. This comes under Rabi crops. And there are some definitions related to this topic you should know before solving the numericals. Gross commanded area. It is the area up to which irrigation canals are capable of supplying water for irrigation purpose. Okay, it is represented by GCA. Cultivable command area. It is the area on which crops can be grown satisfactorily. CCA. Then cash crops. Crops like vegetables, fruits are cultivated by farmers to sell in the market to meet the current financial requirements, and they are called cash crops. Then crop period. It is the period required by a crop from the time of sowing to the time of harvesting. Then crop rotation. The process of changing type of crop to be grown in the same field is known as crop rotation. It has been found that if same crop is grown in the same land every year, fertility of the land gets diminished and crop production is reduced. The necessary salt required by the same crop for the growth is exhausted. If crop rotation is adopted, fertility of soil is restored. So this is the advantage of crop rotation. Base period or base, it is B, represented by B. It is the period in days during which flow is continued for a particular crop. That is, the time between the first watering of the crop at the time of its sowing to its last watering before harvesting is called the base period. Okay. Then duty and delta, these two are very important terms. Mainly the water requirements of crop is on the basis of duty and delta concept. Each crop requires certain amount of water after fixed interval of time throughout its period of growth. As the amount of each watering and the interval of watering and hence the number of watering are fixed for each crop, the total quantity of water required by each crop is also fixed, and it is different for different crops. The depth of each watering is usually from 2.5 to 4 inches depending on the kind of the crop. The total depth of water in inches required by a crop to come to maturity is called delta of the crop. Okay, it is nothing but the total depth of water in inches required by a crop. So the amount or total depth of the water required by the crop is called as the delta of the crop. The area that can be irrigated with a continuous non-stop supply of irrigation water at the rate of 1 cumex throughout the base period is called duty. Duty is the area that can be irrigated with a continuous non-stop supply of irrigation water at the rate of 1 cumex throughout the base period. That is called as duty. So duty and delta are very important terms in water requirements of the crops, and based on this you have to solve the numericals. We'll discuss in detail in the next class. Thank you.